Germany, near Munich. Just to show you, here's the small city, 5 kilometers away from my apartment. And it's a very nice old town. And myself, I'm working in a small software house near in this small city. And we are producing and selling tools that makes the life on the IBM I easier. So our newest tool is a web tool that allows you to write web applications without knowing anything about HTML, PHP, JavaScript, etc. You only need to know RPG. And if I'm not programming, I'm working in consulting, in education, and I speak quite often on conferences. I was in the US 4 weeks ago. I'm next week in the US again, and hopefully to see you everybody in Sweden this fall. And now let's start with the recursive common table expressions. So what I wanted to do today, we want to start with a select statement because we need to know how the select statement look like and where we can add information so we can analyze our recursive data. Then after the select statement, we will talk about common table expression because for one solution, for one way to analyze those recursive common table expressions, we need recursive common table expressions. So we talk about the table expressions, and then we will see the other way. The other way is much easier, but unfortunately not standard, but it's a way how Oracle, for example, analyzes the recursive data. And this is named hierarchical query clause, and we will analyze it. We will also see the value statement, and I think time will be over, even though I normally have much more information about everything. But what I want to do is to show you those information, and I like to show you the information live so that you see, okay, if you don't understand my English, you may at least understand the select statement or the SQL code. So I'll jump between my presentation and my SQL script and show you the examples. Now let's start with the select statement. Okay, select statement consists of select, and within the select row we can select columns, fields, we can use scalar functions, we can use user-defined functions, we can build new columns. Then in the from clause we can join tables and views and files together, also execute UDTFs, user-defined table functions, inclusive all joins. Then we can add where conditions. We can accumulate the results by using a group by clause and selecting information with a having clause. What we see here in the screen, this is called a subselect. Multiple subselects can be merged by adding an union or an except or an intersect clause. Union will merge only those information together. Intersect will return the result or all rows that are identical in both select statements, and the except will return all rows that are either different or do not exist in the other table. So we can merge everything together. Then what you have not seen within the select statement is the order by. Order by is outside the subselect, and sometimes people have problems if they generate a new field and give them this field a name. These names cannot be used within a subselect, but they can be used in an order by clause because the order by is outside the subselect, and we can merge multiple subselects together and order the final result. And this is not everything. What we still use, what we see here is in full select, but we also have common table expressions. And those common table expressions are important for our recursive common table expression analysis. And this is common table expression is something like a temporary table or a temporary view that only can be used in composition with the final or the full select statement of the select statement. And then we have some other information, fetch first X rows only, or for update off, or optimize for X rows. That are additional things that are also part of the SQL statement. What we see here is SQL statement how it was at release 5.4. Then with release 6.1 we get several additional information. So with 6.1 and later we can add an order by or fetch first row only clause into the subselect statements. And finally, with release 7.1 TR5, we get the hierarchical query clause, which is start with, connect by, the way how to analyze queries with the way Oracle does it. The other way is the recursive common table expression. And now let's start with the recursive common table expression, which is a standard for analyzing it. No, with the table expression themselves. So the common table expressions are part of the SQL select statement. They were already introduced with release 5.4, and they are specified before the final select statement. We can add multiple common table expressions to a single select statement that are only temporary tables that can be used only in this final select statement. And the best thing is we also can use common table expression in other common table expression. We can join them together. We can accumulate them. We can join, we can do almost everything. And these are temporary tables, so temporary views that are only valid for the SQL select statement. So you never need any temporary tables anymore. And even so, they are very powerful, and you can split complex SQL queries into smaller parts. The SQL statements will still be readable. And those common table expressions or those views are even more powerful than permanent views, because we can add an order by or fetch first X rows clause in this common table expressions. Now just let's have a look at an example with a common table expression. I just jumped to my small script. We have here a very, very simple sales table, which consists of the customer number, the item number, the item descriptions, then we have the sales date and the amount. And we want to analyze, to accumulate those SQL or those amounts together. Now let me go back to my session because it's easier to explain here. Here we start with a common table expression. We have to name it. Okay, this is an X, and then we have S, and we define the select statement. So in this example, my first common table expressions takes the sales statement, selects all rows or all sales from the year 2008 to the year 2010, and then accumulates it on the customer number, on the year, and accumulates the sales. So this is the first common table expression. Its end, the open parenthesis is closed now. Then if we want to add a second or third common table expression, we simply add a comma, and then we define the next one. The Y common table expression is based on the X common table expression, means it only looks at the sales from the year 2008 to 2010, and then accumulates it again on the sales year. And here in the final select statement, we join the X common table expression with a Y common table expression using the year, and then we take all, or we show all columns from the X common table expression, add the total year, which is defined here in the second common table expression, and finally we calculate percent. We calculate the percent of the year, of the sales of the year, and order the result depending on the sales year and the customer number. So if I go back to my example, here is the same thing. We execute it, and here is the result. So we have the customer number, the sales here, and then the total customer per year and the total per year. And here you see we have the 100% of the year in the year 2008. Then we have it in the year 2009, and here we have it in the year 2010. And now we can calculate percent based on this total year, and here are the percentiles. Okay, this was only a small introduction how common table expressions work. And now let's go to the recursive common table expressions. So it's only the example we have seen before. So if we have a look at the recursion, I asked Wikipedia, what is recursion? So one thing, or there are two things that are very important. It is defining an infinite statement. So that means a recursion can be, for example, a train plane or a flight plane. So I can go from A to B. I can also go from B to A, and I can do a round tour. So theoretically, there is no end. And the objects are repeated in a self-similar way. What does it mean for us? So if we have a look at the tables, how it is, there are two ways of hierarchy of recursive query. The first one is a very easy thing. It's a top-down or hierarchical query. Means I start, for example, bill of material or organization chart. We start with a person in the organization chart and want to know what are the subordinates of this person. Or we want to start with in a bill of material with a final product and then want to know all components of this product. So this is a way how it works, and that means if we look at a table, we have some information. For example, the employee number in a column in a row, and this employee number will be the boss of the next level. So that means this employee number might be in another column in the same table and in the column boss, and then we have to join them together. That means the employee number is for the next level the boss number, and then we have to loop through all our records until the lowest level. So we need to specify a parent-child connection and loop through everything. I said it before, we have the hierarchical relationship, which is very easy. The bidirectional relationship or the two-way relationship is much more complicated because if we go down, we are sometime at the end. The other way is we can go into a loop or into a cycle. So I go from A to B, then to C, then to D, and then back to A, and then I go around. So we have to stop those cycles or to avoid those cycles. Now let's have a look at the examples. We need, for the traditional way, we need a recursive common table expression. That means we need one thing, we need to specify where we start. It's the first thing. And then we have the level, okay, we know the employee number now will be the boss of the next level. So the trick is we have to join this common table expression with itself and with the next, with the table itself, and go down through all levels. Sounds complicated, but if you have understood it one time, so it's you can repeat it whenever you want. It's also possible to include those recursive common table expressions in views, so everybody can use it. It can be used in an embedded SQL, you can use it in PHP, you can use it for downloading into Excel, etc. So if you have reduced those complexity into a view, so it's easy to use. Now let's have a look at an example. I have a very small organization chart, which is has only 3 levels, starting with Mr. Meyer or Mrs. Meyer. Then we have the next level, which is Huber Bauer, then the 3rd level and the 4th level. The table for this organization chart looks like this. So that means here we have the employee number, and here we have the column boss, and we have the employee number for the next level here in our boss column. If we have a look at this, we start with Bauer, which is a number 202, and the 202 is in the boss column for the Becker and Ackermann. You see, it's the next level, and here on the next level we see the 303, which is Becker, is now in the boss column for Jäger, Schmidt, and Hund, while the 304, the Ackermann, is in the boss column for the Hermann and Straub. If you analyze it, and if you see the examples, I defined the employee number in that way, so that the 101 is a top level. The next level is a 202 and the 303, etc. So everything that is on the same 100 is on the same level. So if we analyze it and you see the results, you can remember this. Okay, what we want to do the first thing is we want to analyze. We start with Bauer and we want to get the information. Bauer is the first level. Then we want to get Ackermann and Becker and Ackermann, and then Schmidt. Now let's have a look at the syntax of this. Oh, it's the wrong thing. Okay, what we need. The first thing we need, if we execute a recursive common table expression, we need to specify where we want to start. In our example before, we wanted to start with the employee Bauer. So what we need an initialization thing select statement. This is a start position. And then we need one thing I have to specify, and we need to remember it later. It's the same thing for recursive common table expression and also for the hierarchical query clause. The starting point is never considered for a cycle. So if we have to analyze flight plans or train plans, we we can go from A to B, and from B to we are sent to A. It's not considered as a cycle. Only the iteration will be considered for the cycle. So the easiest thing is we have to avoid that we come back to the starting point. The next thing, the initialization, then we have the iterative or recursive select statement, which joins the last level of the previous recursion with the current level, or with a table on the current level. It means the employee number from the last level is now the boss, or will join as boss number with the current table, and then we have a union all that merges all those results together until the end. And we have to put it into a recursive into a common table expression. So we finally need a final or main select statement that executes this common table expression. Now let's look at our table. You have seen it before. It's a staff table, so we have the employee number, we have the boss number, and here we see the dependencies. So now let's have a look at the SQL statement. First thing we need a common table expression. In my here it is staff list, and then I defined 4 columns. I can also define the column names here in the subselect, but it's easier to do it before. Okay, we have the column level, we define employee, we define name and boss. And here in the first common table expression, in the first select statement, here we have the initialization. So I just hard-coded the first level is 1. Then I take the employee number, the name and boss from my staff table and select the name Bauer. Okay, this is a starting point. Now we need the recursion. The recursion means, okay, I need to join my common table expression with the table itself, but we now need to join the employee number from the common table expression, which is the lowest level, is now the boss of the original table. So we join them together and the union all will return everything. So that's our recursion. All together is our common table expression, and then we just execute the final select statement and sort it based on the level. So let's have a look at the example. Here is the SQL statement we have seen before, and we execute it. And here it is. So we have on the level 1, we have Bauer 202. Bauer is a boss from the next level, which is Becker and Ackermann. And then we have the third level, which is Jäger, Schmidt, Hund, Hermann, and Strauss. So that's a common table expression in the basic. And now I just want to show you a few examples what you can do with such common table expressions. But before I go there, because I used it, I will explain you the value statement. The value statement is something like, a statement with which you can execute, for example, a scalar function or test a function or test a user-defined function or test a regular special register, etc. So you simply specify values and enter or add the information you want to execute, and that's it. But it's even more powerful. It does not only return a single value, we also can build tables. That means it can return one column, 1 to n columns, and 1 to m rows. And those values can also be used for building test scenarios. So the syntax is very easy. Syntax which returns a single value means values and SQL expression. And if we return a table, so we simply say values, and then we have different or multiple expressions, separate them with a comma, and in this way we have generated one row with X elements. And then we also can specify multiple rows, so it's very easy. After we close the parenthesis, we code a comma, and then we specify the next column. So the elements on the same level or on the same position need to have compatible data types, but that's it. So just let's have a look on the example here. I just returned the current date special register, or here I tested the week according to the ISO guidelines from the current date. So today we have week 22. Or here in this way, I separated two different things, information with a comma. So we have two columns. And in this one, I built a complete column. The first column here is hard-coded. And in the second column, I convert the current date into character representation of the date. In this way, we also can build test tables if we want to test something very very fast. For example, here can consist of different columns and rows, and can consist on constant values. Okay, and if we want to test something, we like to have those values or those temporary tables in a select statement. So it's very easy. We just specify our value statement here in the from clause of a select statement, embedded in parentheses, and then we need a name for it. So this way we can select this SQL statement, and if we want to work with it, we simply have to name our columns. So in this way, I take the same value statement, then I take give him a name X, my temporary table, and then we have two columns, which is the first one is my character, the second one is my num. And if I do this in this way, so I can use those columns in my select statement like any column in a table. So here we see it. I have the first column, which is my character. The second one is the numeric field. And then in the third one, I just added 10 to the numeric field. Okay, why I told this to you is the following. I just played around with recursive common table expressions, and I also need those information for our web tool. That means the first thing was I want to build a counter. So this way I just execute it, and then I explain the SQL statement. The first thing I have to do with a recursive common table expression, I have to specify a start value, a starting value. So I do not need a select statement in this case because it's hard-coded, it's 100. I do not want to access any table, just start with 100. And then in the iterative statements, I take the number from the recursive common table expression, add 10 from the counter, have a union all that merges all results, but I have to specify when I have to stop. In this way, I said, okay, I stop with the number 250. That means merge as long as a number is not yet 250. And in this way, we generated a number starting with 10, step 10 until 250. Another thing, one thing I used, for example, for credit cards. Same technique, but in this way, I started with the year of the current date. And then I added always 1 to my year, and then I calculate the year, determine the year of the current date, added 10, and said, okay, repeat it for the next 10 years. So in this way, I generated the next 10 years, and I never have to change it because it always takes the current table, the current date, and executes those SQL statements based on the current date. Okay, yet another thing. I have a sales table. I think we have seen it before. It's a customer number, item number, then an item description, and then I have a sales date and an amount. So, and in this table, I do not have sales for every day, but someone wanted to have a listing which has all dates from in a specific date range, all days, and only those sales for the specific date that are existent, and if they are not there, he wanted to say C0. Okay, but I did not have any calendar file. What I did, again, I used a recursive common table expression. I built a calendar with a run date, so I started in this case with November 1st in 2009 and ended with November 30 in 2009, and then I added 1 day to the previous day, so I have a calendar with all days in November. Second thing, second common table expression is I had to accumulate my sales to the date. Okay, and finally I take my recursive common table expression calendar, perform a left outer join it with my second common table expression using the date and the sales date, and finally we get the result. So we have all days in November, and only and add only those sales that are existent all other cells are not available. So in this way, we can use or can build a calendar date. You even can use a calendar and calculate, for example, convert the date into a numeric date and then join it together, etc. There are a lot of things we can do. Or if someone said, okay, but I want to have all days without the weekend. Well, it's quite easy. So we simply add in the where condition of the final select, we execute the day of week ISO from the run date. So if the day of the week according to the ISO guideline means Monday is 1, Friday is 5. So if it's lower than 6, we get only the working days. And here they are, or I added all those day names. So we see we start with November 2nd was a Monday, and here 7th and 8th was Saturday, Sunday, and we did it. Another thing I used was here the day name of my date, and the coalesce. It's a function that converts a null value into a default value. In this case, it's a 0. Okay, and again, another thing that can be done with recursive common table expression. Let's have a look at my address table. So you can see I do not have all customer numbers between 10,000 and 10,020. Means 10,000 is left, 10,001 is left, 10,006 does not exist, and here between 10,011 and 10,016 they are not available. And sometimes you get the question, which customer numbers are free? So this can be done again with a common table expression. So just let's have a look how I did it. I execute it first and then I explain it. Again, I build a running number, start with 10,000, add 1 to the level for all numbers, stop with 10,020. So I have all numbers now between 10,000 and 10,020. And then I had another common table expression that returns only the customer numbers from my address table. It was necessary because it's my blade table, and I could have duplicates. Okay, so what I did now, I take my all numbers and joined it with an exception join, means return everything that does not exist on the level and customer number, and voila, I get the information 10,000 does not exist, 10,001 does not exist, 10,006 does not exist, and between 10,011 and 10,016 they does not exist either, and then we do not have the 10,019. So these are things you can do with a common table expression. Now let's have another look at my example. Again, my small organization chart. You remember, we've seen it before. The first analysis we did was, okay, we go from level to level to level. But a lot of guys say, I don't know like that. I want to go from, if I start with Bauer, I want to go the first branch until the base, then go back, then the next branch, then the next branch, and if everything is done, I go back to the top level and take the next branch here and execute it. So means I want to have this analysis. I start again with the same Bauer, but now I want to have the Bäcker, and underneath the Bäcker, I want to have first Jäger, Schmidt, Hund, and then we go back to Ackermann, and then we see the Hermann and Straub. Okay, there is even a keyword in the recursive common table expression, but you can do it by yourself, and you need it in this way if you want to wrap it with a view, because this information, this keyword cannot be that is available in the recursive common table expression is not allowed in a view. Okay, let's have a look at the original example. So we have level 1, level 2, level 3, and we have our persons. So the trick I have done to get those information was I take the common table expression and added one field, this one, or one column, which is boss. But in this case, I started with the employee number, okay, in a varying character field. Okay, it's the first thing. Then in my recursion, I just take the boss from the common table expression, means the previous level, and then I just simply concatenate a comma and concatenate the employee number in the second one. So if I execute this query, so I get the following information. So we start with Bauer, then we have Becker, the next level is Becker, and here, for example, for Jäger, the next level is 403. So now it's very easy to order your common table expression based on this dependency column. So just let me have executed again. Here I just added an order by dependency employee, and you see we have here now level first, which is Bauer, then we have Becker, and then we get Jäger, Schmidt, Hund, and it goes back to Ackermann and goes to Hermann and Strauss. I want not go now more into depth with the recursive common table expression. I want to present you the hierarchical query clause. As said before, it's much easier to understand. Okay, just for information, recursive common table expression we have seen before. We need an initial select statement, we need the iteration, we need the union all, we need to concatenate the recursive common table expression with itself based on the parent-child dependency, etc. So the hierarchical query clause was introduced with release 7.1 TR5 and is more easier. We also have a two-part clause, which is start with and connect by. So we have the same thing. Connect by handles the iteration, and start with is a starting point. And it's much easier. So the hierarchical query clause, if you remember before, is part of the subselect. It depends what you have in your subselect, whether you have where, group by, or having clauses. The recursive common table expression is specified after those clauses. If you have neither, you start with after the from clause. Then the two-part thing is start with as an initial select state can be compared with the initial select statement, but it isn't. It's much easier. You simply specify I start with a field whatever, let's say with an employee number equal starting point. That's it. And then we have the connect by. In the connect by, we simply specify parent-child, how they are connected. Means employee equals boss, and we get the connection. That's all. And we also have another thing, which is very interesting. We have an order siblings by. Order siblings by means we have a special kind of order by clause that sorts the elements in the child rows. So depending on the name or depending on the customer number or whatever, we can sort those information on the same level. Now let's have a look at the example. As I said, here again my staff table, and here we have from our staff, and I hard-coded it in this way. It's not mandatory. I just started. So, okay, we start with the 202. We can keep it off. Then we have the employee number and the name. Then we have the column. We say start with boss 202, which is our Mr. Bauer. And then I say, okay, connect by employee number and boss equals boss, and it does not work because we are missed something, a very small information, but sometimes they sit before and say, why doesn't it work? I did everything, I have the starting point, I joined the employee with a bus, okay. I forgot one expression, which is prior. As long as I do not specify this prior, so it will stay on the same level, so it only goes to the next row and returns it. If we add the prior, it knows, okay, I have to loop until the end of this information, and we get all subordinated elements, and we get it. Okay, the one thing, for example, if we have component keys, means more information, more than a single compare statement. So the prior has the higher precedence, means we need to set parentheses if we want to have all key columns set as prior. So just let's have a look at the example. It's always easier to understand if you see it, if you see how it works. So here. Okay. Again, I hard-coded my 202 here, which is, as I said before, not mandatory. From start with boss 202, and SQL is based on simple English, so we simply say connect by boss equals prior employee. So in this way, he knows, aha, I need to join the boss with a previous employee, and it loops through. It doesn't matter whether we write it in this way, boss first and then prior employee, or if we write it prior employee equals boss. In both cases, here we start with Becker and we with Bauer, and then we see the subordinated. And one thing we have to admit, before with a recursive common table expression, it analyzes level by level by level. So look at these examples. I said the employee number on the same level have the same first digit. So here you see the difference. The default with a hierarchical query clause is we have the branch. We analyze each branch after the other, and then we go back here. Becker, then we have Hund, Jäger, Schmidt, and then we have Ackermann, Straub, and Hermann. Okay, one thing, what we see here, it's not sorted at all. So for example, it's neither ordered based on the employee number, nor it is on the name. So in this way, we can now use our order siblings by, which is this special order by clause. And let's have a look at the example. So here again, the only thing I changed is I added the order siblings by clause based on the name. So here we see, now it starts with Ackermann, and underneath Ackermann we see Hermann first and then Straub, and here then we have Becker on the next level, Ackermann and Becker on the same level, and then we have here Hund, Jäger, Schmidt. So if we change it, for example, if I say, okay, I don't want to have the siblings, I want to order it based on the employee number, we change it. Now Becker is the first, and then we have 403, 404, 405, and then we go back to Ackermann. Okay, what we have seen before, we always started with a single value. It's even possible to have those, to calculate those single values. For example, here I just started boss equals, and here I specified an subselect. So I said, okay, I will start with the lowest employee number. Okay, in this way it's the highest level, so it's very good. And I know the highest level is employee number 101, that's why I hard-coded it here. Okay, and here we are. Again, we start first with Huber, 201, then we have Müller, Fischer on the next level, then we go 1 to the next level, etc., back to Bauer and everything underneath Bauer. Okay, here I could hard code it because I know it's 101. But tomorrow we will get a new bus, and so my query won't work in this way. So what we can do, there is a new function which is called sysconnect by root, and within the parentheses we specify the expression or the column. Means it returns always the root ancestor for every row. So if we have multiple starting points, or if the starting point will change, we simply can use connect by root and we get the root element. Same thing, we can use this connect by root in either the select row or in the word clause. So we can specify or we can select connect by root, whatever name greater than Bauer or whatever. And cannot be used in the start with and connect by clause. Well, let's have a look on it. So here again I start with, but this time I had connect by root boss, which is my new column, and voila, I got the 101. I'm not fixed on a single starting point, so I can specify multiple starting points. Whether it makes sense or not, have a look at this example. So in the start with clause, I start with boss with employee numbers 202 and 201, or the name must include month. And I execute my SQL statement, and here you see it. Here the connect by root returns the correct bus number. Here it is 202 for Ackermann, Hermann, Straub, Becker, and Hermann Hund. Then we have here the 201 for Fischer and Schulze and Müller, and here we have the 304 for Hermann. So in this way we have the base of this SQL select statement. Okay, here another example. I have multiple starting points. I just said, okay, starting point greater than 200. Yeah, so we get everything. And now I say, okay, I only want to have this connect by root that is greater than 301. Here we have the 301. If you see, we have a lot of 304, 400, etc. So I can add here a where condition and execute it, and here it is. So we get only these things where the bus number is greater than 301, and we get those information. Okay, yet another example. Okay, I know those numbers, but what I like to have is the name of the personal number. So, okay, what I did is I just added a subselect here in my connect by root. So it's a bus number, then I concatenated a blank, concatenated then this subselect, means I need the name from staff where the employee from my staff table here equals the boss of the final staff element, and then I added the employee number and the name as before. And here it is. So now we do not only see the number, but also the name of the starting point, and we can use it in this way. Okay, then we have a lot of other things. So you have seen before, it's ordered depending on the, it analyzes the queries based on the branch. So it goes down a branch, goes back, goes down again. And if we want to have it ordered based on the level, we can use a recursive common table expression, quite sure, but we have additional information that we can use. One of those information, are pseudo columns. That means there are 3 columns that are available, and you can use it in your SQL statement as if there is a table with these pseudo columns. So there are three. The first one is a level. The level returns the level as I simulated before in the recursive common table expression. Means it starts with 1. The start with is 1, and everything depends on the level it is greater or equal to. The other thing is connect by a cycle. It returns an 1 if we have an bidirectional connection or a two-way connection and a cycle occurs, then it returns 1. Or normally it returns 0. So we can use this column to check whether we have a cycle or to remove everything that returns in cycle and use it. Finally, we have the connect by is leave. That means if we have an bidirectional relationship, so it's the same thing, it returns the same information as connect by a cycle. But if we have a hierarchical relationship, it's always 0 except on the lowest level. So if we have no subordinates for a level of one branch, we get returned the 1, and we say, okay, lowest level, we can do it. Okay, just let's have a look at this example. Here I have the level column, and you haven't seen it in my stuff table, and I added the connect by is leave. I start with boss 101, connect prior employee and boss, and order by level employee. And now you see we have 2 on the first level, we have 4 on the second level, and on the third level. So in this way, we can analyze it level by level by level. Okay, we also can use it for another thing. Here I just played around with those level information. I built an I used this kind of SQL statement in our web application again for building my menus. So here I just start again with 2 starting points, and here I build the hierarchy. I have the level and space. It's a scalar function which returns a number of blanks. So what I did is I said, okay, level minus 1 multiplied with 3. So for each level, it adds 3 blanks before the final information. So if I do not start with a boss, with these 2, but with a top, so we see the complete hierarchy of my SQL statement or my organization chart in this way. Okay, then we have another information we need it later for the recursion, which is a new function which is sysconnect by path. Sysconnect by path allows us to connect string information over multiple rows, and I have to specify 2 information. The first one is a expression itself or the column, and the second one is a separator. So it returns a character large object information, and then we can use it. Example here. Oops. Let's connect by path. I want too much. And here it is. So I have my SQL statement, my start with boss, prior employee, and here I thought, okay, take the name, add the separator dash, and I get my hierarchy names. Or here I do the same thing with an employee number as we have seen before with a recursive common table expression. So we can use it for ordering if we put it into a view, etc. Okay. Here in this way, I just added a substring around the connect by because I didn't want to have the first selected. Okay, now let's have a look at the bidirectional dependencies. So if we have bidirectional dependencies, we can run into loops. Means I can go from A to B, but also from B to A. So if I can go from Frankfurt to Köln to Frankfurt back, and then here is a loop. So I need to make sure that my SQL statement does not return a loop. And we need, if we have an hierarchical and bidirectional relationship, we need to add the keyword no cycle into the connect by clause. So just let's have a look. Here is my flight, and you can see we can go from Berlin to Frankfurt, but we also can go from Frankfurt to Berlin. So I just added my recursive query. I said connect by route is departure, arrival, price, level, okay, from my flights, start with Frankfurt, and connect by prior, arrival, departure, and I forgot my no cycle. If I execute it, I get immediately an error. That's the advantage over of the hierarchical queries over the recursive common table expression. A recursive common table expression does not check the cycle. So you need to make sure that you do not run into a cycle, otherwise, it runs forever, and at some time you need to run IPL with your AS400. So you need to be very, very careful. On the other hand, here on the hierarchical query clause, it immediately stops with the first cycle it finds and said, no, that's it. Okay, so what we simply need to add here the no cycle keyword. Okay, I added a few more information. I executed and then I explain it. Here is again my departure, arrival. Then I count the level of connection. I take the level column, which is the pseudo column, display the connect by a cycle in the last column, and then I have my flights. I say, okay, I want to go from Frankfurt to Berlin, connect by a cycle 0. I don't want to have any cycle displayed. And then I start with Frankfurt and connect by no cycle, prior arrival equals departure, and order everything based on arrival, number of connections, and here we are. Okay, and now let's have a look at a more complex query. So here is a combination with a sysconnect by route, with a sysconnect by path, arrival, and I start with Berlin. I only want to have 2 connections, and I do not want to have any cycle. And I start with Frankfurt, prior to arrival, order by level, and voila, here is my connection from Berlin to Frankfurt. I have a direct flight, then I go from Frankfurt to Hanover to Berlin, Frankfurt, München, Berlin, but look at this. That's what I said before. The starting point is never checked for the recursion. So I can come from Frankfurt to Köln to Frankfurt again, and it's not detected as cycle. Same thing here, same thing here, same thing here. So what we can do, we simply avoid, we simply say, okay, you cannot return to Frankfurt again. And just we add arrival not equal Frankfurt, and that's it. So here you don't see any connection for Frankfurt. Everything is great, and we can do it. Just before we end, one thing. We have a price on our flights. So what we like to have is to calculate the total price. And this is not possible with a hierarchical query clause. What I can do is the following. I can use a sysconnect by path, and take the price, connect it to a character, and use the plus sign as separator. So, okay. But yeah, I now can calculate it by hand, or I can use a recursive common table expression. Or what do we do if we do not have something? We simply write a function. Or the other thing, as I said before, the recursive common table expression. I do not want to go into depth, but you see it's a lot more complex than the recursive common table expression, the hierarchical query expression. So I prefer to write a small function. Okay, just look at the following function. I just delete it before I show it to you. It's a complete source code. And this small function is one of the most powerful functions you ever have seen. I just give you half a minute to have a look on it and to guess what happened, and then I will explain it. So, okay, this small function, I just compile it again. This small function gets a string that has a formula, some things into, and this string is calculated and returned as a numeric value. If something goes wrong, a large negative number is returned. So let's have a look at it. I have to create it. Okay, I recreated it. And here, I pass, for example, 3 plus 5 into my calculate function. I get 8. Or a little more complex. 3 multiplied with 3 plus 16 with power 2. It's returned. Or it can calculate everything that SQL understands that returns a numeric value. So in this way, SQL, for example, has an sinus, cosinus, tangents. So you can calculate sinus. Or you pass the current time and the time as string and calculate it. Here it is. It's now 5 hours 4 minutes. I think I have to finish my sessions, but I only want to show you the last statement. So if we put everything together, here is my calculate function. Then I include the sysconnect by pass, where I concatenate my prices with a plus sign and calculate it. Everything that I did before, that's the only thing I changed against the last SQL statement. And now let's execute, and here it is. Here we have the level, go from Frankfurt to Berlin. Here we have the list prices, and here is a calculation. Here is a total cost of my list prices, and that's it. So time is over. I hope you learned something new. If you have some questions, please let me know it. Otherwise, I will send the SQL script or the presentation, as well as the SQL script to Torbjörn, and if you want to have them, just contact him. Or if you know my email address, I can give it to you. It's Hauser. I just type it so you can write it if you are interested in. It's Hauser at SSS software.de software.de, and you can send me an email. So now we have, I think, a few minutes for questions. If there are some questions
Everybody, thank you very much to begin with, Birgitta. Brilliant as always, and you can continue forever. I
Thank
know
you.
that. They all are muted, so I can either unmute everybody and people drop off if they don't have any questions, or they can mute themselves.
Or
Uh,
they just sent me an email or
okay,
things
yeah,
like this.
that's better.
Did you get any emails or any
Yes,
questions
I
about?
have everything, so I can send an email to all in the audience, and then we can give you some instruction how to get hold of you and get answers to any questions.
Okay.
So once again, thank you, Birgitta, and thanks all for
You're
showing up.
welcome.
Um, and as you mentioned, you will go to Stockholm this in October, and of
Yeah,
course, all people are invited. As most of the
to
sessions
come
are
there.
in English, actually, at least
Okay.
50% of
So
them.
even though I have a Swedish name, yeah, my Swedish is rather restricted, but I can say to all of those audience, tack så mycket. I hope I
Tack,
pronounced it
yes, tack
correctly.
så mycket, Birgitta. Tack.
Yeah. Okay.
Bye bye.
You're welcome. Bye bye.
Auf Wiedersehen.
Auf Wiedersehen. Tschüss.
Tschüss.